All right, so this is going to be parametric functions. And if you're watching this and you were in my second period class today, you'll see I actually did make a mistake, and I was wondering why it didn't make sense, and it's because I only did one function. But parametric functions, for those of you that weren't in class today, which is Wednesday, look like this. There's a function that relates to time, and the x value of that function has its own function related to time, and the y value has its own function related to time. So what that means is it's like you're standing on the edge of the cliff and you're going to jump off. When you jump off, you have a horizontal function, which I'm just going to make up to say that it is 2t plus 4. And what that means is your distance traveled horizontally is related to time. And it has no bearing because of the vertical distance. So it's only related to time. You're traveling out at a velocity of whatever. On this example, it's going to be 2 feet per second, and you start at 4 feet at 0 seconds, okay? You also have a function that is going downwards. In a real life situation, it's going to be based off of gravity, but also if you jumped up, that's going to change it a little bit. But in this example, just to make it simple, I'm going to say that your y related to time is negative 3 feet per second plus 40 feet, okay? So we have these two functions. When we're doing this, we're going to make a table for a parametric function that's going to be time, and then the x value based off of time, and the y value based off of time. So we're going to do these. We're going to start with 0 seconds. When I plug in 0 here, I'm at 4. When I plug in 0 here, I'm at 40. When I plug in 1 here, I'm going to be at 6. When I plug in 1 here, I'm going to be at 37. When I plug in, I'm going to do 5 or 6 of these. When I plug in 2, I'm going to be at 8. When I plug in 2, I'm going to be at 34. When I plug in 3, I'm going to be at 10. When I plug in 3, I'm going to be at 31. When I plug in 4, I'm going to be at 12. I'm going to be here 27. No, sorry, 28. 28. When I plug in 5, I'm going to be at 14. When I plug in 5, I'm going to be at 25. So this is kind of what's happening. Now when you're graphing it, you're just going to use these as your x and y values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are going to go by tens. 10, 20, 30, 40, 50. So I'm at 4, 1, 2, 3, 4, 40. I'm at 6, 5, 6, 37. I'm at 8, 34. I'm at 10, 31, etc. So the graph would look like that. So that's making the table of the parametric function. That's graphing the parametric function. What else we're going to do is we're going to solve x of t for time. So I'm going to take x of t equals 2t plus 4. I'm going to subtract 4. X of t minus 4 equals 2t. I'm going to divide by 2. X of t over 2 minus 2 equals t. Now the reason I did that is I can plug I can plug this in for t into the y function and make myself a linear equation. Right here, I'm going to distribute. And then I'm going to simplify. And I'm gonna treat this like it is y of t and it is x of t, but I'm gonna treat it like it's just y and x. And this is actually the equation of this line that we just drew. So that's what we're doing here. So that's making it easier to graph. Now, if you had somebody flying in to save you, Supergirl, flying in to save you. I know that's not how the S looks on her chest, on her cape. I can draw it, but I'm not gonna spend the time. So she's gonna be flying in with a horizontal movement of something like this. And she's gonna be flying in with a vertical movement of something like this. So we're gonna do the same thing that we just did with this parametric function with her function. So I'm gonna solve the x of t for, I'm gonna just treat it like x. I'm gonna solve it for t. So I'm gonna subtract 16. And then I'm gonna divide by -2. Hey, bud. And then I'm gonna plug this into the y. And then I'm gonna solve it. (24). So when we do this, the reason that we do this is we're looking for where these two cross to see if she saves us or not. So we're gonna set our two y equations equal to 0 and just solve them for each other. So -3/2x plus 46 equals -3/2x plus 26. I'm gonna solve for x, so I'm gonna add this over, which cancels out. Which means that there's no way that it can work because I don't have an x left. Let's pretend, for the sake of the people that weren't here, that x equaled 1. Let's just pretend that. So when that happens, I go back to my x of t function and I plug that in to find out what the time is. So I go 1 equals 2t plus 4. Subtract 4, I get -3 equals 2t. Divide by 2 and I get -3/2 equals t. Which means the only way that she could save us is at -1.5 seconds, which doesn't make sense. So that's how we would solve it, but on this example, there is no solution, meaning that she misses us and we die.